Emertxe internship training program. Myself Ankur Yadav and my project partner Sandeep Kumar. We are from Rajki Engineering College, Sonbhadra, branch Electronics Engineering, a final year student. So here I am going to present my PPT based on 4-week learning on Emertxe internship training program. Week-wise concept learning in which we have learned about C programming, embedded system, microcontroller, and last our project micro oven. In first week we have learned about C programming. C programming, it is a general purpose language even though it is applied and used effectively in various specific domains. So why we have choose C programming? Because it is mostly effective than other programming languages. It has more efficiency and run faster than other programming languages. Here I have provided basic structure of a C program, which includes stdio.h. It's a preprocessor directive. A preprocessor directive is which instruct processor to perform this action before code is compiled. Then int main. After that, in curly braces, we have write printf hello world. This statement is going to be print on the screen and return 0 for termination of the program. In this we also use the comments. Comments are used to not display these lines on the screen. So topics we have learned in C programming is data types. Data types are usually 4 types, which includes character for writing characters, integer for writing numbers, and then for writing decimal numbers we use floats, and double for writing long decimal numbers. Then modifiers, it used to modify the behavior of various function and other data types. Conditionals, which are applied on condition, if else and switch cases. Then loops. In loops we have studied about for loop, do and while loops. Operators, various operators are there like assignment and other. Arrays are the data type of same data. Then strings are used to write characters. Then functions are reusable piece of code which we use many times by calling it. An embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. There are generally 2 types of system. These are general purpose system and specific purpose system. The specific purpose system which perform specific tasks that are unique or specialized, like ATM machine. General purpose system to perform wide range of tasks, which includes computers, medical equipments. Embedded system use the communication codes to transmit data between the processor and peripheral devices. Often other embedded system using communication protocol. Generally they comprise of processor, power supply, memory and communication codes. Here is the basic block diagram of embedded system. A sensor is used to fetch the data or real-time data from real world. Then analog to digital converter. It converts the analog data in digital data. Then memory is used to store the data. Then a processor is used to perform processing tasks. And after that, a digital to analog converter is used to present the data for the users. Actuators are devices which convert the one form of energy to another. Then Here are some examples of an embedded system. There are many examples which includes industrial robots, GPS receivers, digital cameras, DVDs player, and we use mostly in electric vehicles that are coming these days, and in hospitals also implanted heart monitor, then in our basic household appliances, and many more examples which consist of embedded system. So what microcontrollers are? A microcontroller contains a fixed amount of RAM, ROM, parallel input-output ports, serial input-output ports, counter, a clock circuit, all on a single chip. Microcontroller is concerned with rapid movement of bits within the chips. It also consists of many bit handling instructions. And microcontrollers are intended to be special purpose digital computers. The all system is on a single chip, and here is the basic block diagram of a microcontroller. It contains ALU, arithmetic logic unit, accumulator, registers, internal RAM for storing data, then timer or counter for counting purpose, then parallel input-output ports, serial input-output ports for connecting with peripheral devices, then interrupt circuits, interrupts which are used to handle interrupts which appear when the system is running. When interrupts appear, the system move to interrupt to handle those. Then clock circuit to match the system with external peripheral device clock, and then stack pointer and program counter. Here in this internship program, we have used a specific microcontroller, which are PIC microcontroller, especially PIC 16F877A. The PIC is one of the advanced microcontroller developed by Microchip Technologies. These microcontrollers are widely used in modern electronics applications. Microcontroller PIC 16F877A is the one of the PIC micro family microcontrollers, which is popular at this moment, start from beginners until all professionals, because it is very easy to use and it uses flash memory so that we can write, erase until thousands times. So simply we can say that it is reusable and we can use it many times as we need it, and it is capable microcontroller that can do many tasks because it has a large enough programming memory of 8K words and 368 bytes of RAM. It has 40 pins, out of which 33 are path input output, and to connect it over its peripheral devices. So here is basic of our project, microwave oven. A microwave oven is an electrical device that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. This includes polar molecule in the food to rotate and produce thermal energy in a process known as dielectric heating. Microwave ovens heat food quickly and efficiently because excitation is fairly uniform in the outer 25 to 38 mm of a homogeneous high water content food item. There are following modes available in microwave oven, which includes micro mode, grill mode, and conventional mode. So we have used lab IDE for development environment and X8 compiler for cross compiling, and then PICSIM lab simulator to simulate the microwave oven, and we have used PIC 16 F877A microcontroller. It is a 8-bit and it has a 5 ports. The port A is a 6-bit analog, port B 8-bit bidirectional, port C 8-bit digital pins used for serial communication. Then 4D 8-bit digital pins. The basic learned before developing a microwave oven. Tactile switch we need to learn before developing a microwave oven. What is a tactile switch? This switch is toggled. Contact have to physically move from one position to another as the component of the switch settle into their new position. This bounces mechanically, causing the underlying circuit to be opened and closed several times. Then interrupts. Interrupts is a signal to process emitted by hardware or software indicating an event that needs immediate attention. Whenever an interrupts occur, the microcontroller completes the execution of current instructions and starts the executing an interrupt service routine. Then matrix keypad used when more number of user pins are required and still want to save the controller input-output lines. Timers. Timers is a specialized type of clock which is used to measure time intervals. It has three modes: PWM or pulse generator, then counter, PW or PP measurement. Now my project partner Sandeep Kumar demonstrate the following project and simulation of microwave oven.
Here it is my main function, and here there are sub functions. This is operation call, where we have declared cooking mode, displaying cooking modes like stack mode, micro mode, grill mode, convection mode. These are all the four modes, and we have used a function called power on screen to print the messages on the SCLCD, and that is LCD. This is a clear display function which is used to clear all the elements or erase every characters present in the LCD. Next, we have set time, which is basically a timer function which will calculate the time between two events. And we have door status, and we have time display here, and we have set temperature. Here we have set the temperature maximum, that is 250. We can set according to our wish. I have set the 250 is the maximum temperature, that is in degree of Celsius, to heat the microwave. This is basically the logic of my program. Yeah, and if we build, the build is successful and it will create a X file. We can extract this X file in PixSimLab. File. Here we have selected PIC Genius and PIC 16F877A, which is basically a microcontroller. Here we have used this microcontroller, which is the 8-bit controller. This is the clock frequency, and this is the heater and cooler. Here is a heater which is inbuilt peripheral in 16F887A. To load, we have to go to file and click on load X. It will show the X file. 8. Yeah. Open. Now I have load. It is powering on. Next, it will show the four modes of operation. First, we will select the micro mode. It's showing that it is using 900 watts, that is maximum power supplied to it. Here we are showing that minutes and seconds. Here we can give maximum of 60 minutes, that is 59 minutes 59 seconds. We can't demonstrate that much amount of gap. We will basically take example 10. See, it's showing 10 seconds. We can even clear that. See, it's showing 00. Now we have selected 10. If we enter, see the time, the fan is rotating and the timer is going downwards. That is, it has started the microwave generation, that is, it has started to heat the food. We can even pause this. See, the way fan has stopped rotating, that is, heat has been generated or stopped. We can even resume and we can even abort the mission. After submission, it will show the cooking time is up. Next, we have three other operations, that is grill mode, which is basically does the operation of a micro mode, but it won't use the 900 watts power. We can even set for a smaller value. I'm setting it is 6 seconds. See, we can even pause the fan and resume it again. We can pause it again and resume. See, cooking time is up, and it will show the main menu. In main menu, it's showing convection. This is basically used to preheat the oven. See 3. It's asking temperature. If we enter more than 250, that is the maximum limit, it will show an error, that is invalid temperature. As I said earlier, we have to set the temperature below 250 degrees. I'm here setting 100. The preheating has been started. To increase the speed, I'm varying the clock frequency so that it will come down faster and we can go to the next operation as fast as we can. See, I think you can notice the difference in the speed. This represents the serial com represents basically the baud rate, that is the communication rate between the two, that is the from processor to peripheral. That is 9600 is the basic thing requirement. See here it's showing okay. I have to set it here again, lower X. Yeah, again see here we have start mode. We have predefinedly set 30 seconds. It will start. You can even stop this thing. See, the fan rotation has been stopped and even the counting has been stopped. Here the cooler, as you see, can also has been stopped. We can even resume. If we don't want to wait, we can even abort or stop the mission. See, this finalizes our project. Thank you for your valuable time. Thank you, Emertxe.